Then group the RAM addresses and data together, pull the CPU out of the motherboard, and look at what's called the instruction set of the CPU. As we saw earlier, some of the pieces of data in RAM are instructions, and each CPU has its own set of instructions that it understands. So there might be a load instruction, which loads a number from RAM into the CPU. After a couple of these load instructions, there might be an add instruction that adds these two numbers together. After an add instruction might be a store instruction, which saves the result of that addition back out to RAM to be used later on. There might also be a compare instruction after some load instructions, which compares two numbers together to see which one is larger or if they are the same. The compare instruction can be very useful when used in conjunction with what's called a jump if instruction. As we saw earlier, the CPU generally requests each piece of data from RAM in order one after the other. Sometimes, though, the programmer wants to jump to an out-of-order RAM address to process some other instructions in memory. The jump if instruction checks to see if a certain condition is true before it jumps. It uses the results of the compare instruction to make this decision. There is also a regular jump instruction that jumps no matter what. Finally, there is an out instruction and an in instruction. These will output data to an external device like a monitor, or input data from an external device like a keyboard. These two instructions are often used in conjunction with an address, like we talked about earlier. There are some other instructions in a CPU's instruction set, but these are some of the more commonly seen ones. So as we saw, the data in RAM consists of things like instructions, numbers, addresses, and letters.